Alright guys, welcome to my very first ever video class. So if it's terrible, just, bear with me. So today, actually wait a minute, before we get started with today, I need to talk to you about your homework. I am not able to be here today, kind of obviously, but I assigned the homework and I told you I was going to check it. So when I come in on Friday, I can guarantee you that I'll be checking both homeworks that were due today. That's the percent composition one. And the one that was, what's it called? Yeah, I told you this is going to be a terrible video, but the understanding chemical reactions. I'm going to check both of those and the homework that is going to be assigned today. And depending on how well everybody does, we may or may not have a pop quiz. So I reserve the right to have a pop quiz. So there's that. I will be checking the homework on Friday when I get back in, and today we're just going to jump right into balancing chemical equations, which is what the next section is about. So in your notes, this is everything from your notes. Take it for what it's worth. This is, again, one of those things where it's going to be easier to do it than it is to talk about it. So basically, here's how balancing chemical equations works. First, you write this skeleton equation. Really, for you guys, it's going to be given to you. And then, to balance a chemical reaction, you count the atoms of each element of the reactants and products. And you got to make the same number of reactants as you have products. So if you have 2 sodiums in the reactants, you have to have 2 sodiums in the products. I mean, it kind of makes sense. I've been talking about this, how you can't magically make, atoms and stuff. You can't make them magically appear and disappear. And so that's kind of what this is all about. It's also about the ratios to make stuff work properly, like we did with the with the balloons. We had a really good ratio of fuel and oxygen. That's why it worked. But the ratio wasn't right. Things just don't happen. All right, so getting back to this, what we do is we got reactants, we got products. We count the atoms of each element in the reactants and products, and then we mess with the coefficients. You cannot mess with the subscripts. You can only mess with the coefficients. If you mess with the subscripts, you're changing the chemical reaction. That is not allowed. And we change the coefficients to make the number of elements equal on both sides. Okay, and this will make a lot more sense once we do 1 or 2. And then, of course, if you're all done and you've got all kinds of wacky numbers, what we have to do is make sure it's simplified. This means that we have to simplify the coefficients. So if you have a 2, a 2, and a 4, that means you have to have a 1 and a 1 and a 2, which I hope makes sense. It'll make a lot more sense once I do 1 or 2 with you together. And then again, as always, go back and double check. Balancing chemical reactions are kind of hard to get wrong because you're going to double check every time, right? Every single time you're going to double check, right? Okay, and so this, the reason why we have to do all this, not only is it because of the ratios that you have to make, make your pumpkin go boom, but also there's this thing, law of conservation of mass. This basically says that you can never create or destroy matter in a chemical reaction ever. It's just like if you start with 5 Lego pieces, you're going to end with 5 Lego pieces. If you start with 10 Lego pieces, you're going to end with 10 Lego pieces. Atoms and molecules, they don't magically appear and disappear. And a balanced chemical equation basically, holds that true. So in chemical reactions, they must have the same number of atoms in each reactant. I'm sorry, I'm going to start over because I should read now. Chemical reactions must have the same number of atoms in the reactants as in the products. I think I've said this enough times. You guys kind of get an idea. Let's just do this. But let me tell you, the first thing you got to do. You see this? You see this? This is junk. You don't want a pen. Get rid of it. What you need to get to balance a chemical equation is one of these things. You need to grab yourself a Dixon Ticonderoga that kind of has the green print. They're good, and especially one with a lot of eraser. Because there is no straight answer for these things. You just kind of got to figure it out as you go, and you're probably going to be using this more than once. So make sure you have a nice eraser and no pens. Don't be silly. Okay, so here's your homework, the one that I want you to work on today. It's called balancing equations because that's what we're going to be doing. We're going to be balancing equations, and here is just how hard it is. We've done this a couple of times. Let me see if I can zoom in here and make this a little bit bigger. Give me a second. Maybe I can. It's new fancy technology. It's not letting me zoom. Alright, I'll watch this. Low tech zoom. There, that's good. Okay. All right, so here's how it works. For number 1, you count the number of hydrogens. I have a total of 2 hydrogens here. And over here, I have 1 hydrogen. And I got to find some way to make them equal on both sides. But I can't mess with this because this is my subscript, so the only thing I can do is this. Write in a coefficient. You dig? Sweet. So, anytime you write a coefficient, go back and start all over again. 2 hydrogens. 2 times 1. 2 hydrogens. Sweet. 1 times 2. It's 2 chlorines. 2 times 1 is 2 chlorines. Sweet. That one's done. That was super easy. Not even scared of that one. That was great. Alright, now let's do number 2 here. We're going to do the exact same thing as we did before. I'm going to start with the first element, and I'm going to count. 1 calcium here. 1 calcium here. Oh, that's awesome. Okay, so in this case, here we have a polyatomic ion, right? And this little subscript right here, that number 2, see how it's pointing to your little parentheses here, your parentheticals? That means there are 2 NO3s, and like just like everything else when we were doing our like chemical formulas and the naming and whatnot, you treat your polyatomic ion as if it's one thing. This is one block of polyatomic ion, you know what I mean? And there are 2 of them. Get rid of that so I can see now. So there are 2 NO3s over here. Over here I have only 1, so I'm going to fix it like that. Nice, and anytime I add a coefficient, I'm going to go back and start all over again. 1 calcium, 1 calcium, 1 NO2, I'm sorry, 1 NO3, 1 NO3. I've got 2 hydrogens here, 2 hydrogens here, 1 SO4, 1 SO4. This isn't even hard. This isn't even hard. I can do this. This is easy. It's easy. I can do this all day. Not even kidding. I totally can. All right, number 3. Here we go. Let's start. 1 iron. Super easy. 2 chlorines. 3 chlorines. All right. So here, when we have numbers that are a little bit weird, lowest common denominator, or least common factor, or whatever you mathy people like to call this. Between 2 and 3, it's going to be 6, right? That's the lowest common denominator, or lowest common factor. Again, I don't teach math, but you guys know what I'm talking about, right? So if I need to make this chlorine, if I need to make 6 chlorine atoms, I'm not allowed to mess with the 2, so what am I going to do? How do I get 6? Very good, right. All together now. 3, yay! Alright, okay, it's coefficient, I gotta start over again. 1 iron, 1 iron. 3 times 2 is 6. I'm gonna do that. 2 times 3 is 6. Awesome. So I just put in the coefficient, I gotta start all over again. 1 iron, 2 irons. Okay. 2 iron. That's a lot better. 2 irons. 3 times 2 is 6. 2 times 3 is 6. Sweet. Everything's all done. Easy. This gets a lot easier if you do a couple of things. 1, start with the first element, and then go to the next one, and then go to the next one, and then go to the next one right down the line. And always, 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 after you write down a coefficient, go back and double check the whole thing, because everything's kind of like related to each other, so you gotta like, you just gotta go back and double check to make sure that things haven't been like knocked out of whack. Okay? So, I mean, that's it, guys. This is how we do balancing chemical equations. Want you to do the rest of these, 1 through 10. It should be pretty stinking easy, and this you should be able to have done by the end of class, no time whatsoever. But you know how I roll. There's never just one side to a homework assignment. It's like that's not how I roll. You know there's going to be 2 sides. Oh God, look at all this. Are you serious? Yes, I am serious. I need you to get all these done, okay, guys? Here, let me get that back in focus for you. Oh, this stupid thing. There you go. How's that? Is that better? There. I need you to get these done for tomorrow. Again, same exact thing over and over. You got to change the coefficients, but you can't mess with the little subscripts, okay? Feel free to work in groups. However, I will say that when it comes time for the quiz, you're not going to be allowed to work in groups. So you can work in groups to try to get through all these, but make sure that you each individually know how to get this done, okay? So remember, I'm going to be checking this for tomorrow, along with your other 2 assignments that were supposed to be ready for today. And depending on how many people actually do their homework and get this all done, we may not have like a pop quiz. So happy Thursday. We'll see you tomorrow, guys.